let's start with the first question. Okay, the first question, a lot of people, when they do this kind of question, if they do not remember the now factor law, that means they are going to just leave the 6 on this side. When they leave the 6 on this side, then they are going to maybe think of maybe 6 is equals to 2 times 3. So you will say, oh, one of them is 2, the other one is 3. Okay, but don't forget, if you were to be able to put 6 into 2 times 3, you can also put 6 into 1 times 6 or 2.5 times something, or maybe 1.5 times 4, and there are a lot more possible answers. Okay, so by leaving the 6 on this side is definitely cannot, because there are too many different possible ways to break the 6 into, right? So how are you going to compare? So they will come up with infinitely many solutions. Okay, so the only thing that you want to put is to put this side to be equals to 0. Okay, remember the one side must always be equals to 0, then the other side we try to factorize, and then we use the now factor law. Okay, so over here we expand this out, we get 3x squared, okay, plus 5x, am I right? 3x squared plus 5x minus 2, and I also at the same time subtract 6 from both sides so that this right hand side becomes 0. Okay, so this is 0 now. So later I'm going to factorize this and then use the now factor law. So 3x squared plus 5x, okay, minus 8 equals to 0. Okay, so I'm going to factorize it to be 3x and x, and then I'm going to have 8 and 1, so that if I want the middle term to be a 5x, I put a plus 8 and a minus 1 here, so that actually when I expand this out, I get 8x and minus 3x together is 5x. Okay, so this is 3x squared, this is negative 8, so it fits into this whole thing very well. Okay, so we can say that this left hand side can be factorized to be 3x plus 8 and 3x minus 1 equals to 0. So now you see that the left hand side is a product of two factors, and the product of two factors is a 0. That means one of them must be a 0. So either the first one is a 0 or the second one is a 0. So if the first one is a 0, you're going to get 2 and 2/3, and if the second one factor is a 0, you're going to get 1. So these are the answers for question 1. Okay, so remember one thing, must always put one side to be equals to 0, and you use the now factor law to solve. Okay, most of the quadratic equations are always done this way. 98 times 102. Okay, some will say, oh, I just use calculator, I can get answer already. But this question, you cannot use calculator. You have to use algebraic results to do. Okay, so you have to think of how do you make use of the algebraic result. Algebraic results are mainly on the three identity: a plus b squared, a minus b squared, and then a plus b times a minus b. Right, so which one then we can use? Okay, so you can actually see the 98 and 102. Both of them, you can say the 98 is 100 minus 2, and then the 102 is 100 plus 2. So you are actually using this third identity to do. Okay, so 98, put it into 100 minus 2, and then 102 is 100 plus 2. So you see 1 plus 1 minus. When you expand out, you get the square of the first number minus the square of the second number, because a plus b times a minus b will be equals to a squared minus b squared. So we are making use of this 1 with a 40, which is actually 10,000 minus 4. So you are getting 9996. So 9996 should be the answer. Okay, 9996. Okay, question 3. I think among all the questions, this is probably the most difficult one. Okay, you are given first the base of a certain triangle, okay, is given to be this expression. The height is going to be this expression. And now you want to find the area. Okay, so area, so everything is in algebra, right? To find the area, we know that it's half base times height. Okay, you learn in primary school, half base times height. Okay, half of base, here base is x plus 2 divided by x squared minus 1. Okay, x squared minus 1. And then the height is x squared plus 2x minus 3. Okay, we are not going to write everything here. There must be some parts that maybe can be simplified. So we try and see, we factorize it and see whether we can factorize it to become okay, sorry, this is x plus 1, x minus 1, and x plus 2. Okay, numerator is x plus 2, no change. Denominator, x squared minus 1, I factorize it to be x plus 1, x minus 1. Then this height here, I also factorize it to be x plus 3 times x minus 1. Can you see that when I expand this out, I'm getting this one, okay? So, and x minus 1, both of them have x minus 1 in the denominator and x minus 1 in the numerator. Okay, so therefore I cancel this 2 and I don't have any more to cancel. So I have 2 times x plus 1 is the denominator and numerator is x plus 2 times x plus 3. So this is the answer. Okay, this is the answer for the area in terms of x. Okay, in terms of x. Now the next question is, if the area decreased by x plus 3, so what is if the area is decreased by x plus 3, it's not the length or the base is decreased, it's the area. So this whole thing is the area, right? So now we want to find out what is the new area. New area, right? So the old area, which is x plus 2 times x plus 3 over 2 times x plus 1, we want to subtract away x plus 3. So that will be our new area, because the old area minus the decrease. So that is a new area, right? Okay, of course, again, whenever you have expression which is algebraic expression, you always have to combine and simplify. So over here, we try to combine them. We have this 2 of x plus 1 as the denominator. So this first term is x plus 2 times x plus 3. Whereas this one here, we multiply 2 times x plus 3. So we have to put 2x plus 1. We multiply 2x plus 1. So you see, I have to multiply this one here. Can you see that if I use this, divide by this, it still come back to x plus 3. Okay, then next one is I have to simplify. So you can see, I'm not going to expand it out. I'm going to do factorization. Can you see that the common factor is x plus 3? Right? So I'm going to take the x plus 3 out. X plus 3 out. So I'm going to have x plus 2 minus 2x minus 2 over 2 times x plus 1. So here, 2 plus, a plus 2, a minus 2, negative 2. So together I simplify to this 2 gone already. So x minus 2x will be equals to negative x times x plus 3 over 2 times x plus 1. Okay, so this is a new area. The next part is they tell you that, okay, if the area is decreased only in the, I think in the height, okay, only in the height. So what should be the new height now? Okay, so this is the new area, and then we know that the decrease is only in the height. So that means height is something that is variable, right? height is something that is changing, so which means the base is going to be fixed, right? So we're going to use back the base to do our calculation. Okay, so we fix the base. Okay, we fix the base, we use back this base to do our calculation. Okay, remember the area is half base times height. So if I want to find height, okay, if I want to find height, which is actually the new height lah, okay, the new height, I'm going to use 2 times of area divide by the base, right? So 2 times of the area, so I'm going to use 2 times the area, okay, 2 times the area, so twice of the area, right? Okay, then divide by the base. So what's the base? Divide by this means I'm going to divide by x plus 2 over x plus 1 and x minus 1. Okay, so I'm going to do division. I'm going to do division. Okay, so here, how do I divide now? So I'll have 2 times negative x and then x plus 3 over 2 times x plus 1. Divide means times, the reciprocal. So I flip the fraction. Okay, I flip the fraction. So now I get this. And the only thing that I can cancel is the x plus 1. Okay, the x plus 1. And maybe the 2 also. Okay, maybe the 2 I can cancel. I think that's all. Okay, so that's all. So what I can do is, okay, I may want to put the negative into the other one. So I have 1 minus x, and then there's a x, and then there's a x plus 3, and then there's a x plus 2. Everything combined is this. Can you see it? Can you see it? So you see I have a negative here. I can multiply into here so that there's no negative here. So I multiply into this one, it becomes 1 minus x. Okay, this x plus 2 is x plus 3. Okay, clear? Okay, so this is question 2. This is very tedious algebraic calculation. Okay, very tedious. You have to be very careful, and you have to try to put everything to be factorized form, can be handled easily. If you were to expand everything out, it's going to be extremely more tedious than what we have here. Clear? So among all the questions, this is probably the most difficult one now, huh? Okay, can understand or not? Can be done. Okay, so that's why I was asking, is there anything wrong with the question? So it doesn't seem to be able to make things simpler, right? Make things simpler. So it's not really, if the bottom is like 6.5 and 3.1, then possible to simplify lah. Okay, never mind, we skip this question. Okay, we skip this question. Okay, come to the next question, B. Okay, B is also similar way, but just now we use a squared minus b squared. Now we're going to use bringing out common factor. Can you see this, like a times b minus a times c, right? So there is a common factor of a. So which is the common factor? You actually, it looks like 426 is a common, but it's not. Okay, it should be this one is the common one. Okay, 0.6789. So 0.6789, okay, be the common factor. So you will have 1426 left for the first term, and then 426 left for the second term. So here the difference is 1000. So you are getting 0.6789 multiplied with 1000, which is 678.9. So this is a very good example of how you can use algebraic results to solve a simple a certain expression that looks like quite tedious if you really even to use the calculator to calculate, right? So the numbers going to be big numbers, but if you do it in the algebraic way, you see that the common factor is this. Okay, so 1426 minus 426, which is 1000. So 1000 times 1000 means just move the decimal places. Okay, move the decimal places. Okay, question 5. Okay, question 5, to factorize. Okay, to factorize. So if you were to look at these two terms, you want to find a common factor, you can't, right? There's nothing common, right? There's nothing common. So if you look at this one and this one, maybe you have a b that's common and a 3 that's common. But after bringing it out, it doesn't seem to help much, right? So what we can do for this kind of question is we will try to, can you see that this 4ax squared and 12bx squared, they should be related. And then the 3b and a should be related. Why so? It's because when you see these two, the common factor got x squared and then got 4. Right, so 4x squared is a common factor. If you were to bring 4x squared out, the first term will be with an a. Then the second term will be with a 3b. Can you see? The a plus 3b. Now, there's another a plus 3b over here also, which is minus of a plus 3b. You see? So it's minus a minus 3b, so it's minus a plus 3b. So here, common factor is a plus 3b. So take the common factor out. So you will have 4x squared minus 1. This is like 1 multiplied with this. Okay? Is that the end? If the question just asks you to factorize, you can say you have factorized already, because why? You put it into product of two factors already, factorized already. But if the question say factorize completely, means you are not done yet. Why is it that you are not done? Here, there's no more common factor. But this one can further be factorized. Okay, this one can further be factorized to be 2x plus 1 times 2x minus 1. Okay, so this is a plus 3b times 2x plus 1 and 2x minus 1. Okay, this is then complete factorization. Okay, so this is question for 5, question 5. Now, question 6 is the changing subject. Changing subjects, this one involve the square root. Okay, involve the square root. So you have to, okay, let's see, involve the square root. So the method still the same lah. Okay, every time when you do changing subject, how do you see, how do you simplify it? You can see, first you want to find w to be the subject, right? So you want w to be the subject, and then w here, you can see that w, first it subtract d, then after that the whole thing times 3d, then after that divide by 8, then after that take square root. Right, so can you see that the step is the w go to minus d, then after that times 3d, then divide by 8, then take square root. So the very first thing that we remove is the square root. So if we do squaring on this side, we are going to get s squared equals to 3d w minus d over 8. That's the first step. Okay, second step is divide by 8, the last one, right? So now we times 8 to both sides. So 8s squared equals to 3d and w minus d. Okay, next one. 3d was multiplied to w minus d. So now we divide both sides by 3d. So we have w minus d. Can you see that? Okay, so if I want to find the value for w, so I'm going to get 8s squared over 3d plus d. Because I keep this, I remove this by adding. So I add. Okay, so you can either leave this as the answer, or you can put the 3d to be the denominator. So you have 8s squared plus 3d square, 3d square. Okay, because this one divide by this, then you get your d. Okay, so either this or this, both are okay. Okay, so these two, either one of them can be the answer. Okay, check your answer and see, are you getting the same answer? Okay, which part that you have to improve? Okay, so checking your answer, everybody checking your answer. Okay, next question 7. Question 7, to expand. Okay, to expand, just like x plus y squared. So what we do is just x squared plus y squared, then plus twice of the product of x and for y. Okay, here this is a squared over b squared. This one answer is 2, and then the next one answer is b squared over a squared. So expanded already lor. That's all. No need to go and no need to go and combine again. Don't need to combine. The question asks you to expand. Expand means what lor? Term by term already lor. So this is the answer. Okay, so same for the second one, the b. If you want to expand, okay, so you will do like, okay, I use this x times everyone. Then after that, I use 2 times everyone. Okay, so I'm going to keep this one and use x to multiply. So I get 2x squared minus xy plus 3x. And then 2 multiply in, so I have 4x minus 2y plus 6. Okay, so that's for the first part. Okay, then the second part, I have minus x squared plus xy. Okay, so now I have 1, 2, 3, 4, 5, 6, 7, 8 terms. Okay, among these 8 terms, some of them can be simplified. Okay, like 2x squared minus x squared, it will be x squared. Okay, then minus xy and plus xy, same value but one positive, one negative, so can cancel. Then 3x, 4x together is 7x. And then y, there's nothing to simplify, so it's just negative 2y and plus 6. And that's all. You are left with 1, 2, 3, 4 terms. So from 8 terms, you go to 4 terms. So we simplify already. So we expand already, you cannot stop here, okay? You got to simplify until like this x squared, there's no other x squared. This x, there's no other x. This y, there's no other y. And this constant, there's no other thing. So they are all by themselves. Okay, cannot simplify, cannot combine with any other terms already. So that's that. Okay. Next, to factorize this, okay, whenever involve 2 terms, you either consider that they have a common factor, or you, okay, we first bring out the common factor first. The common factor will be 9. So 9 minus x4. Okay, so this is factorized already. Actually, this is factorized, but if the question say factorize completely, then it is not complete yet. There's still some more. Okay, so because why? This is actually 3 square, and this is actually x square square. Right? So we can further factorize it to be 3 plus x square and 3 minus x square. Yeah, is it done? Yes, it is done. Okay, why? Because here this 2, nothing common already. This one, actually, if this is 9, you can further factorize, but this is 3. So 3 is not a perfect square. Unless you want to say it's square root 3 plus x and square root 3 minus x. But I think we are dealing with just rational numbers, so we don't combine into irrational numbers. So this is good enough already, so we will stop here. Okay, then the next one is 8a, and okay, thank you. So here we have, yeah, he break out. Okay, so this one you have to go and, when the numbers get big lah, so you will have to go and try a lot in order to get the right combination. So he put it this way. Okay, so that this is negative 36a and this is negative 6a, so together is negative 42, which is what you want here. Okay, so you have 4a minus 3 times 2a minus 9. Okay, thank you, Wen Qian. Okay, so this one okay, so please, when you reach here, stop already there, because why? 4 and 3, no, nothing common already there. 2 and 9 also nothing common already. So stop here, don't give me the answer a equals to 3/4 and then or a equals to 4.5. You are not solving equation. This is not an equation. This one you just factorize and then you are done. Okay, you are not going to solve it. It's not equation. Reminder. Okay, next one. Okay, next one, I can see that the 4 and the 4. Okay, so probably I will bring the 4 together. So can I say p squared minus pq minus 4p plus 4q? So I'm going to group the 4's together, the p's together. So here, the common factor will be p minus q. Okay, p minus q. So here, I take a negative 4 out. So I also have p minus q. See, p minus q, p minus q. So the p minus q is a common factor. So I have p minus 4. Okay, so factorized. This is by grouping method. So grouping method, just like just now. Okay, I can choose to rearrange the terms. Okay, I can choose to rearrange the term until it fits me well. Okay, you can also do it straight away like this also can. That means you put p out, then you'll get p minus 4. Then this one also, you take the q out, then p minus 4, negative q. And then you are going to get the same answer. But for me, just I feel, I prefer to put the 4 and 4 together. Okay, so different ways of doing. Okay, finishing, last page. Okay, it's 11:46. Okay, I try to do it fast. Okay, next is this one here. I want to make P the subject. Can you see that the P is spread all over the place? So what I'm going to do is I'm going to spread out. I'm going to make this to be like over 1. So I'm going to use Q times 1 plus P squared. Okay, and then 3 minus P squared. Why I do this is because I want to spread out the P and Q, and then I'm going to group all the P's together and all the Q's together. So can you see that I'm having these two terms with P's? Okay, so I'm going to say 2p squared q plus p squared will be equals to 3 minus q. Now what I have over this side has nothing to do with p, because I want to make p the subject. So my p should only stay on the left hand side. Okay, so my p should stay only on the left hand side. So now p squared is a common factor. So I have 2q plus 1 is 3 minus q. Okay, so here, can you see? My p squared is out already. So my p squared will be 3 minus q over 2q plus 1. So you see, if I want to make p the subject, on the other side of the equation, there should not be any more p. If I have some more p, means wrong already. Okay, because I want to make p in terms of other things, not in terms of itself. Okay, if you have in terms of itself, then later you want to find p, you are not possible to find, because on the other side you got p, but you don't know what's the value of p to substitute. Okay, so next one, so I want p, not p squared, so I'll have plus minus square root of 3 minus q over 2q plus 1. Because of the square, there's a positive negative value here, both positive root or negative root. Okay, next one, I want to make t the subject. Now t is here only, right? So t is here, so I'm going to keep the t, the term with t here, and I'm going to put 2q minus p. 2q minus p. Okay, I want to make t the subject. So what do? Okay, I can take this as like over 1. So my t value will be equals to kp over 2q minus p. And I'm done. Okay, I'm done. Yes, I'm done. Okay, why? Because my t is a subject. Then the other side got no more t. Right? So all in terms of other thing. See, first I keep it on one side. You know how I do this part from this step to this step? Is something like cross multiplication. Okay, cross multiplication. I have kp times 1 equals to t times 2q minus p. So what is the p? T will be kp over 2q minus 1. Or you can also do this way, like you can say, okay, kp over t equals to 2q minus p. Okay, flip over, take the reciprocal on both sides. So take the reciprocal, so you get this. Okay, so I want to keep t, right? So I need to remove kp. How do I remove kp? Is I times both sides by kp. So kp over 2q minus p. This is also another approach. Okay, a slightly different way of doing. Okay? Okay? Yeah. Then last one. Okay, indices. Indices. Okay, I have indices here. I like to do the negative powers to make it positive. So how do I do it? So can you see that I have 3 and b squared? I'm going to put the a squared at the denominator, then cube of it. Okay, then the next one, 6a cubed over b squared. And then I want to take the negative 2 power, right? So here, I don't have negative power, so I can straight away say that this is 27b6 over a6. Okay, what about this one? I have a negative here, so I have to take the reciprocal of it. So b squared over 6a cubed to the power 2. So I actually have 27b6 over a6 times, this is b4, and then 6 squared is 36. Then a to the power 3, then to the power 2, so to the power 6. And so my final answer is going to be 27 over 36 is 3 over 4. Okay, I divide by 9. Then B, I have 6 here, 4 here, so altogether 10. Then A, I have 6 here and 6 here, so altogether 12. So that's the answer. You got the same answer? Okay. Next one, simplify. When you see something a squared minus b squared, what you do is just take a plus b and a minus b. Okay, divide by, okay, here everyone has a term of x here. So I take a x out. So I have x minus y plus 1, which is x minus y plus 1. This whole thing is the same as this whole thing. So I can cancel them. Okay, so my answer is just x plus 1 plus y over x. Then the very last question, to simplify, we see that there's nothing common that we can bring out. You see, this is u minus b, this is 2 minus u, totally unrelated. So what we can do is just expand out and simplify. So 5u squared minus 5uv plus 6v minus 3uv and then plus 5uv. So a plus, a plus and a minus, okay, and any more that we can simplify. You see, u squared, there's no u squared, v, there's only one term of v, and there's one term of uv, so nothing else already. So what we do is just collate all of them together, and that's our answer. Okay, so if there are 10 questions and then it is 100 marks altogether, can you count and see how many marks you get?